Lesson 5-6, graphing inequalities in two variables. So our objective today is to graph inequalities correctly by shading and the correct type of line. So we're not talking about single variable and graphing on a number line like we've done before. This is basically graphing lines because there's an X and a Y. And then you're going to graph the lines, you're going to shade the sections and things like that. So we'll talk about that a little more in depth when we get there. The rules for this are similar to what we had when we graphed inequalities on a regular number line, except we're talking about graphing full lines. So if you come up with a greater than or less than, that is merely a dashed line. It's simply a border. The line isn't included. It's greater than that line, or it's less than that line. It's not the part of the line. The part of the line is not part of the solution. But once you switch to or equal to, greater than or equal to, less than or equal to, it is a solid line. So basically what you want to think of is the dashed line is equated to an open circle, where a solid line would be similar to a filled-in circle because that line is part of the solution. All right, when you are graphing these, you definitely want this to be y equals mx plus b form. Of course, it's not going to be equals. It's going to have an inequality symbol, but you want it in the form of slope-intercept, so that you can easily graph. You'll put the point, the B point, the y-intercept on the y-axis. You'll count your rise over your run, and then you'll decide whether it's a dashed or a solid line and put that in. Now, the shading has to come into play next, because when you're talking about graphing a line that's an inequality, you're shading a whole section of the line. It's like you're splitting the graph into two parts. The part that's the answer and the part that's the not answer. The part that's the answer is the shaded part. So here's kind of how you do this. If it is greater than or equal to, then you want to shade above the line or where the greater y values are. So greater than means bigger, so you shade up or above it. Less than or equal to means lower, so you shade below or to the lower y's. Okay, so I'll show you some different examples as to why it says below or smaller, why you just can't say below. All right, so those rules you might want to keep handy as you're doing this or getting started. Let's go look at some examples now. This says graph y less than or equal to negative 3x plus 4. Okay, so I'm going to start off with my y-intercept, so I'm going to put a point at 4 on the y-axis. Oops, I better put it as a point, huh? And then my slope is negative 3, so I fall 3 and run 1. I look at that symbol, less than or equal to. That means that my line is also part of the solution, so it is a solid line. And less than or equal to means that it should be below or the smaller y values, which means that I would shade all of this. Now, when you guys shade, you can use the side of your pencil and literally shade it in. With this thing, I can't really do that, so I'm just going to kind of do lines. Shaded below. Now, here's something that is really important. Use a test point to check your solution area. What's happening here is the whole area that is shaded. Any point in that shaded area, you should be able to plug into that inequality, and it should be come out to a true statement. If you can test 0, 0, it's always the easiest. In my graph is 0, 0 in the shaded area or not shaded area? Shaded. Shaded area is the solution. See, shaded area is all solution points. So, if I test 0, 0, it should be yes, it should work. Here's what I mean. 0 in for y, I'm using this, is less than or equal to negative 3 times 0 plus 4. 0 less than or equal to, well, negative 3 times 0 falls out, and 4. Is 0 less than or equal to 4? Yes. So we have the correct section shaded. One piece of advice, you might want to do the test point before you actually shade. Okay? So you tested if it's correct, then you shaded the right section. If it's not, then you didn't shade the right section. And I'm going to do one just to show you. Let's say I pick out, let's see, here's 1, 2, 3. Let me do 5, 5. 5, 5's out here somewhere. It's not even in it. Let's test 5, 5. I want to show you how it should not work. So we would say 5 is less than or equal to negative 3 times 5 plus 4. So 5 is less than or equal to negative 15 plus 4. And then 5 is less than or equal to negative 11. True or false? False. Correct. That is not a solution area, so it will not work. So all of the solutions are in the shaded area. All of them make that inequality true. Questions? All right, let's go down to this. Graph 2y minus 4x less than or equal to negative 6. Of course, that's not pretty, is it? I've got to redo this. 2y minus 4x less than negative 6. I need it in y. I'm going to put equals, even though we know we really don't mean that. mx plus b form. I need it in y equals mx plus b form. So I'm going to add 4x to take it over to the right. 2y is less than 4x minus 6. And I want y alone, so divide everything by 2. Y is less than 2x minus 3. So negative 3 is my first point. Slope is 2, so rise 2, run 1. It is less than, so it is not included. The line is not included, so it is literally a dashed line. And less than would be below, but I'm going to test it. Now, if I pick my favorite test point 0, 0, should it be true or false? False, because it's not in the shaded area. And you can test it that way too. That works. So 0 less than 2 times 0 minus 3. 0 less than negative 3. True or false? Is 0 less than negative 3?
False.
That's false. Is that good? Yes, that's good. It tested out. We're right. 0, 0 should have been false. It's not in the shaded area. Okay, the last two. It's going to explain the lesser numbers, I hope. Y greater than or equal to 2. What kind of line is that? Zero's fun. So y at 2, it's a solid line, so it'd be a horizontal at 2. It says y greater than or equal to 2. Where would the y's be greater than or equal to 2? Up here. You would shade up here. X greater than or equal to 2. When there's only an x, what kind of line is it? No slope, so vertical, so x at 2. It's greater than or equal to, so that's a solid line. Where are the x's greater than or equal to 2? Where would it be? To the right. You'd shade everything over here. The tricky part about this is sometimes you might get this y greater than or equal to 2 and you get confused and you put it on a number line because there's only one letter. But definitely today, these are all linear inequalities, and you graph them as linear inequalities. Questions? It's just when there's only one letter, it's going to be horizontal or vertical. What you need, Ethan?
So with this x, how would you do it? Why would you do it on the right and not the left?
Where are the x's bigger, Ethan?
On the right side.
Correct. All right. Now, the assignment for today is a little different because there's not many problems. So we're doing skills practice and practice. Also, there is a quiz tomorrow over Chapter 5, everything we've done.